We're live.
Thank you. Hey, Jason, sorry to interrupt. We're not hearing your audio. You might need to restart the presentation. Okay, everybody on the webinar, we're just having some technical difficulties there. We weren't able to get Jason Luke's audio and introduction, so we're just going back to the top here. Welcome to Keoak Academy, Canadian Underground Institute for Infrastructure. Today's presentation is going to be on the City of Calgary, Bearspaw South Feedermain emergency response and repairs. Just a little bit about Keoak Academy. This webinar is organized by the Canadian Underground Infrastructure Innovation Centre through the University of Alberta and Benjamin Media. This, in addition to other classes and courses, are intended to further the underground infrastructure educational opportunities across Canada. These webinars occur third Thursday of each month and include industry-leading professionals providing a free educational webinar to the public. Today's presentation, I'm going to go through the presentation in a minute here, and this is going to be followed by a question and answer period. Some upcoming Keoak events in Calgary here next week, May 21st. We're restarting. So Keoak Academy events upcoming. You can find these online for registration, May 21st, 22nd in Calgary. There's a horizontal directional drilling school. And then in Edmonton later in the fall, Keoak Academy, Safety Academy. These are both in-person events, providing good training opportunities if you're able to attend. We want to say thank you to the webinar series sponsors, Ackerman, supporting underground infrastructure, education, and innovation. So just a little bit about myself. I'm not going to go into the full bio here, but my name is Craig Pass. I'm with Associated Engineering in Calgary. For this project, I was a deputy project manager as well as the field lead, providing construction and field support to the city. This was over all 3 phases of the repair project in the field full-time, managing our staff, surveys, geotechnical, all of our subs, and having that on-site field presence was able to support the city and quickly help resolve the water emergency. Just a quick overview here of our scope of services that we provided the city to support this. This is also a rough outline of the presentation for today as well. We're just going to go over kind of the emergency response. During that time, the initial days, we provided review of city's pumping data and also provided operational assistance. We looked into some initial failure modes to look at some possible causes and try to start determining what might have caused the failure of the initial rupture. We looked at, or we did complete transient analysis to determine if transient event contributed to the rupture. Throughout all of the phases, we were supporting the city with a forensic investigation. So that included collecting field data, reporting on potential causes, and trying to look into like what might have contributed to the June 5th rupture, but also some of the other distress pipes that the city was seeing in this Bearspaw South feeder main. We won't really get into the details of the forensic investigation, but I will note that the Associated Engineering report is available to the public. It is posted on the city's website, and if you're interested to know more about the forensic investigation, you can visit the city's website. AE also support the city in reviewing proposed details for the repair. Later on, when we transition to instead of replacing the distressed pipes, we transition to enhancing the strength or re-strengthening the existing pipes in place. Throughout, we provided survey, geotechnical, geoenvironmental services. In parallel with the repairs, we also support the city with valve chamber modifications to deploy acoustic fiber optic monitoring. And then overall, there was a tandem memo looking at short and long-term repair recommendations. Just to give you an overview of some of the key features in this presentation and just where this project occurred in general. This is an overview of City of Calgary. City of Calgary is serviced by two water treatment plants, Bearspaw and Glenmore. They have a combined capacity of about 950 megalitres per day. In general, Bearspaw supplies the majority of the City of Calgary's treated drinking water. And from that Bearspaw water treatment plant, there's three main discharge headers. There's one to the north, one to the northwest, and then the subject of today's presentation, the Bearspaw South feeder main, 1950 millimeter, and it roughly connects the Bearspaw water treatment and the Glenmore water treatment plant. This slide here is a graphical representation by percent of volume of the overall system. So you can see here, the lines are each showing, kind of a graphic representation of how much flow each part of the feeder main transmission system is delivering throughout the city. So Bearspaw feeder main, between those two blue dots, that is the largest pipe by volume within the entire transmission network. This is supplying into the Glenmore pressure zone, which covers about 90% of the daily water supply within the city of Calgary. So this would be considered a critical main, very large piece of infrastructure for delivering treated water throughout the city of Calgary. Just a little bit more of an in-depth view of the project location. So Bearspaw water treatment plant on the left of your screen there, the red line representing the 1950 or the 78-inch Bearspaw South feeder main. Portion of the feeder main is steel pipe, and then the other portion that we're looking at today is the C301E pre-stressed concrete pipe, which runs for about 8 kilometers through this project area. Looking at some of the repair locations, so the red arrow indicates the June 5th rupture. The June 5th rupture was the initial emergency response and the immediate repair to return the system to service. During the initial rupture, other work was proceeding, being coordinated by the city to look into other potential distressed pipes and broken wires within the pipe network. But this is just a rough overview of the initial June 5th rupture. And then we proceeded to phase 1 repairs, which were targeted 5 repairs on another series of pipes that were demonstrating a large number of wire breaks. And then further rollout, looking at additional stressed pipes or distressed pipes with large number of wire breaks in phase 2. And then finally, phase 3, this is on the 1500 millimeter or the 60-inch section of the pipe, which is further east of the Shaganappi pump station. So this was completed last. 2 segments of pipes were repaired there. So looking at the pipe that, this is not the pipe that ruptured, but this is a typical example of the pipe that is the subject of the presentation. So the pipe was C301E pre-stress concrete cylinder pipe. This particular pipe was manufactured in 1975. And in exhuming the pipe, doing cores, all this, the cross-section of the pipe you can see here, it consists of an inner core of about 50 millimeter lining. There's then a thin steel cylinder about 2 millimeters thick. The steel cylinder is what provides the integrity of the pipe. This is what contains the water and the pressure. And then overtopping the steel cylinder, there's about 110 or about 4 inches of concrete core. This is then wrapped with the pre-stressed wires, which holds the shape, holds the water in. The steel cylinder provides a containment, the pre-stressed wires providing the structure, and then the pre-stressed wires are then covered with about a 2-inch or 20 mil mortar coating. So you can see cross-section there on all the distinct layers of the C301E pipe. Just a little bit more detail on these pipes. So constructed in 1975, the Bearspaw, so Feedermain, so the main portion is 78-inch, manufactured at the time by Canron, and then also the smaller diameter pipe further to the east, 1500 mil, 60-inch Canron PCC pipe, and supplied in various lengths here. Getting in a little bit more detail to the June 5th rupture. So on the afternoon of June 5th, I recall I was leaving a golf tournament, and some interesting tweets started to hit the news, or X's, starting to see some murmurings of like there was something going on in the system, something not at your typical water main break. And so yeah, on June 5th, there was a catastrophic event that caused a rupture in the Bearspaw South Feedermain. AE was contacted by the city, and we were able to attend site immediately and start supporting the city on trying to determine what happened and supporting in investigation and repairs. So just cite here pictures showing 16th Ave with the water surcharging to surface, and then also a picture of the distress pipe with the rupture. Once all the water got pumped down, we started getting in close up to the pipe, looking at the wire breaks, looking at the damaged section of pipe, and starting to gather information to support the forensics investigation. Looking at where the pipe failed, so we found a crescent-shaped tear at about spring line on the pipe. With the rupture itself, there's about 200 pre-stressed wires that were found to be broken. It's not able to be definitively determined how many were broken before and how many were broken due to the rupture. But you can see here, this is the rupture from the steel can within the pre-stressed cylinder pipe. So again, we were able to finally get the pipe out of the ground, looking at it a little bit more detail here. So this is the pipe segment that ruptured, that crescent shape tear just below spring line, I guess. And yeah, so this pipe was taken to one of the city's yards for further investigation, and then sampling the mortar, sampling the steel, doing a full suite of material sampling, so that additional forensics testing could be completed to determine the cause of failure. In parallel with that, and kind of just touching on some of the other support that Associated was providing to the city, we wanted to, look into the pump data leading up to the event. Was it a pump failure? Was there a pump that kicked on or off suddenly? Was there a transient event? So the city was able to provide us their pumping data. Upon review of the pumping and then the transient, we were able to determine that the rupture, the June 5th event, was not due to a pumping occurrence or a transient event. So those are some things that we were able to review and initially rule out. So some of the first very immediate needs, obviously, we needed water. Pretty much immediately, there was water restrictions enacted by the city, but at the same time, we needed to get water into different pressure zones, keep water in the system, keep the taps on to some degree as much as possible. So with AE's recent experience in the city at Bearspaw Water Treatment Plant, also Shaganappy Pump Station, we were able to support the city in reviewing bypasses within pump stations. We were also able to leverage our recent experience to get some plans put together quickly and get into construction. And then also knowing the system, we were able to install a pressure reducing valve to be able to operate the system in an emergency operations. So on June 6th, we got into Shaganappy Pump Station and were able to identify ways that they could change the operations, run water backwards, if you will, and be able to supply some of the different pressure zones in different ways and keep water going to the pressure zones and the different reservoirs throughout the system. One of the solutions that we developed in the North Hill bypass, so getting water to pump station 32, we actually straight lined a pipe. So normally there would be a pump at this location, but we were able to identify if we remove this pump and straight piped it through here, through the pump station, that we'd be able to run the water backwards and still be able to provide water into one of the pressure zones. So that was leveraging our recent experience and support on a variety of different city water projects. Getting back to the June 5th, so this would be termed the emergency repairs. So from June 5th to June 15th, these initial repairs on the ruptured pipe were completed by the city water services. They did have repair adapters in stock. So there's a critical supply, a stock of critical materials that is stocked at their Bearspaw yard. And they did have in the diameter and the size, in the case that there was a rupture or failure, they did have a stock of materials on hand. And this was used to replace the ruptured C301E pipe with a section of C200 pipe. So this was the initial repair was done with on-hand materials. While this pipe was out of service, the city also began to collect other information from within the isolated portion of the Feedermain. So at this time, they were able to deploy Pure Technologies, who did electromagnetic scans of the pipe. And during this initial window, that is when the information was collected to provide that indication that there were other distressed pipes with significant amounts of wire breaks within the system. And the city started to develop their plans to complete subsequent repairs on additional pipes. Once those additional 5 locations were identified, the city developed their own detail that they looked to AE to complete reviews on. So this was going to utilize welding in donuts into the bell and spigot of the existing C301E pipe, and then we're going to transition to C200 steel pipe. The supplies for this were all procured by the city. This was all done in a rush fashion, and the very first slide that we had there was that kind of famous stick of pipe that came from the San Diego County Water Authority. So that was sent up, very graciously donated by San Diego County to support these repairs. So that was one piece of pipe, but all the pipe needed to get rushed up to Calgary, lined and coated and prepped up to be ready for the repair. As I mentioned, while the initial rupture and the out of service was in place, the city completed electromagnetic scans of the pipe. This was achieved by, since there's no water in the pipe, by dragging through electromagnetic equipment by Pure Technologies. And through this, they were able to identify pipes that needed to be repaired based on the number of wire breaks. Taking this information, AE needed to translate it to the field, right? So this is collected in the ground, but we needed to know, where are we going to go dig? Where are we going to go find these pipes? And so one of our initial tasks was going through. The city did have all the original layout drawings of the Canron pipe that we were able to review and look through the Pure data and correlate, drain points. There were obviously a lot of valves, but there's drain points, other features on the Feedermain system, air valves, things like that. And from those points on the lay drawings, the Pure technology information, and then field checks, we were able to go out and lay out and say, dig here. I recall one of the most nerve-wracking things was showing up on June 16th. The city had already lined up all their contractors in place to complete the emergency repairs. They were already digging. They had a rough idea of where their pipes were, but we kind of view this as like, you only have one chance to get the right pipe. We didn't want to have to dig twice on anything. So contractors are already on site, asphalt's out, already starting to dig, and running up and down the street with Pure, with drone surveys, trying to take the information from these old drawings, which are in feet and inches, the other data that's in meters, and trying to lay everything out and get the pipes right and make sure that we're digging and repairing the correct pipes. Another reason why this initial layout was important was to support our forensics investigation. So we had identified these distressed pipes that were going to be replaced with sections of steel, but at the same time, we wanted to exhume and extract these segments of pipe so they could be taken off site for further forensics analysis. So once we determined which pipes, we also laid out where the zones that we did not want any cuts. We wanted to try and exhume these as intact as possible for future investigations off site. And then you can see here, in addition to doing the survey layouts and things like that, Pure also came back onto site and completed additional EM scans to make sure the number of wire breaks that we were seeing from the internal scans and the pipe diver were matching kind of like the signature of the pipe on site. And through all the phases, so there was a total of 3 phases, 29 locations total. We were successful in locating and digging on the pipe 29 out of 29 times. So that was, it was pretty nerve-wracking, but was successfully executed. Again, supporting the city's, forensics investigation. We were completing site observations of the in-situ pipe, making observations, collecting mortar samples, looking at the wires, just trying to collect as much data as possible to help support the forensic investigation into why this might have occurred. In addition to this, Core Pro was on site looking at resistivity, straight current analysis, things like that. And then Thurber was supporting AE as well to collect soil samples for testing for chemical properties. looking a little bit more along when we started to dig out the pipe and start getting it ready for replacing with steel. One of the things that I guess I learned through the course of this project was the amount of time that it took to chip out these diapers. So the mortar that was applied at the joints, you can see in the lower view of the slide on the left, the concave at the joints, those are, referred to as diapers. That was very high strength material. And I give credit to all of the crews, working so carefully to protect these joints. So they needed to chip out these diapers while not damaging the existing bell and spigot, because that's what we were going to go weld the donuts in and weld the steel pipe right into those bell and spigots. So very careful exercise, very time consuming. This was probably the activity that took the longest. I think up to 24 hours, 24 to 36 hours to chip out each diaper, multiple crews getting in there, and just really tough work. And that probably took the longest out of any of these site activities. So once diapers and the pipes removed out of sight, the steel pipe brought into site, so lined and coated. You can see the adapters that were fabricated, so welded right into the existing bell and spigot. So C2 200 pipe dropped in there. The closure was completed with butt straps. And then in addition to the lining and coating, everything was dead stone mastic before backfill. So just as we kind of transition from like the phase one, so like these were repairs on 5 locations. One of the locations, we came to find that there was a thrust block that enveloped portion of the pipe that was distressed. Since this was a significant thrust block and we didn't want to start removing that, risk damaging other pipes, things like that, we started to look at other possible repair methods rather than doing a replacement here. Structural Technologies was brought to site at one point to look at external and internal fiber wraps to reinforce the pipe. In the end, the city elected to go with a concrete reinforcement around the existing pipe to, reinstate that hoop stress and, help keep the shape of the pipe, keep the water in the pipe. So for this one site, we started to develop the concrete encasement design. And as we move into the phase 2 repairs, this was what we applied for 21 additional locations. So after the initial phase 1 repairs were completed in June, we had time to reconfigure, come up with more plans with the city, their contractors, and starting in the end of August, we deployed to complete repairs at 21 additional locations. At this point, the city brought on Graham Contracting. So the phase 1 repairs were completed by 4 separate contractors working directly for the city. But for these phase 2 repairs, it's a very wide area, multiple work fronts. You're within residential areas, commercial areas, very, very high density urban area. They brought on Graham Contracting to act as a general contractor for these 21 sites for the overall program. AE's services in the phase 2 repair. So we did, as I mentioned, we've prepared the concrete encasement details that were going to be constructed around the existing pipe. So we needed to support the existing pipe in place. So we also looked at the support details and how much deflection could you, or we're trying to avoid having any deflection, obviously, but coming up with your minimum deflection and providing the requirements to the contractor to make sure that it's properly supported in place at all times, so the concrete encasement could be constructed without compromising any joints and loss of integrity. Again, through phase 2, we're completing forensic analysis on the distressed pipes, collecting information, This view here just kind of shows how close we were to residents and homes in the area. You can see a yellow Pelican box in the one slide there. That's vibration monitoring equipment, which was deployed by Thurber. So we're doing vibration monitoring, we're doing the layouts, the pipe checks again, and supporting the city through the collecting data for the forensic analysis. We did have a video planned, but unfortunately due to technical difficulties, video is not available. Just looking at a bit more detail of the phase 2, so 21 locations over a wide area. Graham came up with the work plan to phase and stage all of these work areas. They assigned the work to 4 different civil contractors who are responsible for, excavating and exposing the pipe, and then Graham themselves perform the services to, place the rebar, place the concrete encasement, things like that. The shoring system that was installed was used as part of the formwork, which worked out quite well. So these are, obviously pretty large rebars. And I recall when these shop drawings came out, we had to work with Graham quite a bit to, find all the available rebar. I recall there was many calls, where are we going to get all this rebar? There's rebar couplers, all these different pieces that we needed to get on very short notice. I think all I think this is 40 W40 rebar. I think we got every piece in the province or something like that, getting it shipped down to Calgary on rush delivery, and then getting new core in there to bend it all, get it all in place, and everything came together seamlessly, that it was executed very well. Just a view here of the concrete encasement in place here. You can see the girders there that were used to support the pipe in place. Those were just cut and cast in the concrete. And photo of us there on the last day. So this was when we had completed the last inspection of the pipe, did the forensic reviews, and within the last couple of weeks of getting everything wrapped up there towards the end of September, myself and Jacqueline Lee, who was my project engineer, supporting me on site there. The final phase of the repairs, so these were the 2 60-inch segments, or 1,500 mil segments of pipe. So similar approach to these ones of our AE's scope, at least, of collecting data, forensic support, and then we had already developed the repair details in the previous stages. These 2 segments were replaced rather than repaired in place. So these pipe segments were removed, and in this case, they were replaced with the steel adapters and replaced with steel sections of pipe. In parallel to this, other work that AE was supporting the city on, so they did go ahead and start. There was no monitoring systems in place at the time, so they needed to make modifications to the existing system, existing valve chambers, to install acoustic fiber optic monitoring. So the system is deployed to listen for wire breaks within the pre-stressed concrete pipe. We helped the city, I think it was 5 different locations, modify existing valve chambers, complete cores into the valve chambers, put manholes on top, support the city with positioning the fittings and things like that within the valve chambers to be able to deploy the AFO monitoring. And then, we call these things like the plumbing stack. So they were attached to different blind flanges, different air valves were removed, things like that, to be able to deploy the AFO cable within the Feedermain, pull it through, get it to a monitoring station, and get it up and over the different butterfly valves that were within the system. I have this one as takeaways. I'm still learning from this project. This could have been lessons learned, I guess, but kind of my own personal takeaways from this is the safety. So safety was paramount at all the meetings. That was very key. The city had a great overview on all the safety throughout all of the phases. This work was completed as like 24/7 emergency repairs. There was crews working night and day in busy areas with lots of public, and successfully completed with no major incidents. So a huge credit to the city and their contractors for working safely throughout. It was really neat to work on this project, all working towards one common goal, which is returning the water to service. The city, the contractors, the consultants, everybody. Is really neat to like the team attitude, and it was a really neat experience. So communication, so early and often communication, not relying on email. We were in the field, we're making decisions in the field, we're in site trailers, everything happening in real time. And then just, having that internal and external communications at all times. With any kind of major field activity, obviously having that office support as well, and then the backups and things like that. So having, plans for cross training, cross shifts, having, your backup, the person who's going to cover you, and making sure that you're able to have those handovers. So AE developed for our own work, at least we had a SharePoint where we had live notes, team chat, photos, everything in there. So we were able to communicate through that SharePoint and Teams platform to, here's what happened today, here's what's plans for tomorrow, and be able to have a really good plan in place for making sure that everybody was up to speed and being prepared for those cross shift. And then just, being adaptable with that willingness to work together. It was a really neat experience to be able to work in the field with the different contractors. We came up with all these plans, really quickly, but then when you start digging, things change, things are different as always, right? But just being able to have that collaborative approach and be able to work together with the contractors and the city to achieve that common goal. Just a couple quick acknowledgements at the end here. Obviously, it's a huge project. We provided a scope and service to the city, but it was a huge team, and just want quick thank yous to the City of Calgary, Volker Steven, Standard General, Whistle, LB North Star. Those were the contractors that were involved with those initial phase 1 repairs. Graham Construction was brought in for phase 2, and they subbed quite a few of those same contractors to complete those repairs. Phase 3 was completed by Graham again with LB. And just the relationships built there. I think everything went so smooth, and it was really neat to be a part of that. Throughout this, of course, working with Pure Technologies. So that was a great experience for me as well. And then just thanks to the Associated Engineering sub. So Thurber, who provided the forensics, collecting mortar samples, collecting cores of the pipes, material testing, vibration monitoring, drone surveys, doing survey layout scans and as-built, and then CorePro doing forensic straight current and resistivity testing. So with that, thanks Kiewit for having me. Thanks for the opportunity to present today, and look forward to answering any questions.
Excellent. Thank you, Craig. Can you hear me?
I can. Welcome back,
Excellent.
Jason.
Thank you for doing my job for me. Great presentation.
Yeah, that was, just wing it. Yeah. Thank you.
Great presentation. Thank you very much, Craig. We got a few questions here. So we got some time for some questions, and we'll go back and forth. So if you have any questions, please put them into the box there, and we'll pick through them. So we got a question here from EPCOR up in Edmonton. By reversing flow through the system, to what extent during the repair were there any significant water quality issues downstream?
Yeah, great question. Not to my knowledge. That was something that was managed internally by the city with our operations and water treatment team. And through my experience in the project, that's not something that I ever heard. I wasn't directly involved, but nothing that I was aware of for water quality issues. But I know that, prior to in-service, different things like that, the city was conducting water quality testing throughout.
So then maybe building on the water quality discussion, just in terms of how the repairs were done and how pipes are being replaced on the out of service sections. How was the feeder main disinfected, I guess, before it was put back into service?
I'm not recalling that at the moment. I know that, obviously the filling and the draining that took, similar to the diapers, that probably took even more time than the diapers to fill and drain this line. I can't recall that. I wasn't directly involved with any of the water quality. So
okay, no, fair enough. On that initial break on June, I think it was June 5th, right? When the initial break happened there. When you shut down the pipeline, how far away were the valves, like to isolate that section?
Right. So isolations were completed up at Bearspaw Water Treatment Plant. And then there was only 2 other isolation valves. So valve chamber 1 and valve chamber 2. So valve chamber 2 was adjacent to Shaganappy Pump Station. I might see if this works here to go back to a slide here. So if people can see the screen here, you can see the 2 valve chambers. The valve chamber 1 in the middle, that wasn't, I don't believe it was used for isolation, but the valve chamber 2 by Shaganappy Pump Station was closed, and then at the water treatment plant itself.
Okay. Maybe going back onto the discussion about reversing the flows, can you comment a bit more in terms of like how we figured out how that could happen in terms of, and more so like, taking, how that reversal kind of happened to kind of serve. And I think if remember, there's a reservoir up to the north there.
Yeah.
Can you just some general commentary related to how that reversing kind of worked?
Yeah. So AE was able to apply our direct experience. So AE did the design on the Shaganappy pump station, which was key in a lot of this here. So, you can see in the upper right of this screenshot here to the North Hill pressure zone, right? So this was a bypass to provide service into that North Hill pressure zone. And from our experience, and then also our knowledge of like the city's transmission system, the pressure zones, things like that, we were able to identify this opportunity through our direct experience. And so that was led up by our process mechanical group, Joe White, and with direct hands-on experience and the knowledge of the pump stations.
Not sure if you can answer this question or not, but what kind of saw was used to cut the pipe?
What kind of saw?
Yeah. Like a normal concrete kind of, what do you see in concrete? Like it is, because it's the pipe there with the wires and the cylinder, what is like just normal concrete?
On the initial break, I wasn't involved on the initial rupture and cutting it out. I know that one of the contractors to remove one of the pipes brought out the high pressure water jet cutting. But typically the process so aside from this initial rupture, the process that the contractors used was, to chip out the diapers, and then they just pulled the pipes out. There was some cutting, but yeah, it's typically done with just, typical saw cutting equipment and being able to like pull out the first section of pipe and then get at it in smaller pieces, get to the surface, and then cut it on the surface rather than in the trench.
On the concrete cylinder pipe, is there cathodic protection on that pipe?
No, there is no cathodic protection system there.
But on the new pipe, like the replacement pieces, I believe there was cathodic protection added, correct?
Yes. Yeah, I believe I'll I'm not 100% sure on that
So-
actually, because there's no existing cathodic system. But I do recall that the city had cathodic staff on site to test for that. There is the steel system, right? So the steel system does have cathodic, and that was something people were wondering on, is like, was there any cathodic that was, you know, being put through the system from the cathodic that was on the steel? Yeah.
I think, if I remember correctly, I think each section of new steel pipe that was added had like some anodes added.
Yeah, it would have been just buried anodes and test points. Yeah,
But it wasn't.
There were buried anodes and test points put on the steel pipe. Yeah,
but it wasn't. I don't know if it was like integrated with the rest of the the system.
Just each section.
Quick another here about the going back to the concrete encasement, because I think you mentioned that the pipe was supported while the excavation was done around. I think it was like 21 places there where there was a concrete encasement done. So the pipe was supported, and then were the supports cast in place like once the concrete was there, like the supports were left in the ground, or?
Correct. Yeah. So you can see in the slide, and apologies if it's the left or the right, but you can see the girders, you can see the slings and the ratchets hung off of the girders, and then like the fabric tethers were kind of below the level of the concrete. So yeah, those fabric tethers are cast in place, or were cast in place, and then they just cut them off once it was supported by the concrete encasement.
Going back to the concrete encasement here, continuing that discussion, what were the specifications there in terms of like strength on that concrete? Do you know?
I don't know off the top of my head.
And how far below the pipe did you go?
I'll just bring up the detail. I think it was about 500 mils, I recall, on all sides there. And so our structural engineers, AE structural engineers, came up with the detail. I can't recall the strength on that, but it was mostly, obviously the majority of the strength with the rebar design, very heavy rebar reinforcement in here. Not recalling the concrete mix design though, the strength there. But yeah, about 500 mils all the way around.
Can you comment on why we went with the concrete encasement option as opposed to maybe other rehabilitation or strengthening options?
Yeah, I think based on the number of repairs, so this was 21 locations, and just from that experience gained in the first one, it was something that could be, replicated and repeated to a certain degree, fairly cost effective, local, reasonably local materials available, the contractors in place, and being able to replicate, repeat over 21 locations. And then also, I think with the staging and the other requirements, it was just kind of determined that to meet the schedule here. So this was all 21 locations completed in about a month, in about 4 weeks. Being able to dig down, excavate, support, tire the rebar. It was just based on the repeatability and the schedule that we're looking to do this in. It was determined to be the preferred method. So in the background of all this, one of the other things associated was supporting the city was preparing a memo with short-term, long-term repair options. In terms of long-term repair, one of them was to recommend a twinning of this feeder main, and the city is actually undertaking design of a twin trunk to provide redundancy to this existing feeder main.
Very good. Lots of questions here, and again, some dialogue also. Dan Nelson, City of Calgary, there was a question related to the cathodic protection. And he confirms here, no cathodic protection on concrete, but anodes on the new steel pipe. So,
thanks for that, Dan.
There was another question about the backfill around the cast in place repairs.
Yeah.
Was there any special requirement for the backfill in that area then afterwards?
No, there was not. It doesn't have a photo of it, but in the video, it would have showed it. That it was all backfilled with fillcrete. So you can see, like in around the trench box, they were using soil bags, like cubic meter bags of sand and gravel to protect the trench. And then, yeah, these were removed out. The gravels removed out. Everything, the concrete encasement was all backfilled with lean mix or CLSM concrete.
We'll see. I'm not sure if we can answer this one or not. Was there any issues in terms of isolating the feeder main, say valve operations, those kind of things?
No, not that I recall. It was successfully isolated using the valves that were in the system. So yeah, there's valve chamber 2 here. There's another valve chamber further to the east, valve chamber 3. I can't recall if that one was closed or not, but yeah, no, there was no issues to isolate it after the initial repair, after the initial rupture.
So this pipe here is about a little bit over 50 years old, but we didn't install any new valve chambers as a result of this, correct?
Correct. Yeah, no new valve chambers. Some of the additional work that took place in parallel with this is that there were a couple of cross connections to the distribution system. And while the pipe was out of service, the city replaced all the valves on the cross connection. So AE supported that design and replacement as well. So these are connections to like the 400 mil, 300 mil distribution system cross connections.
And then I guess the second part of that question, and I guess this was an emergency kind of response as opposed to any kind of long-term planning. But can we comment if there's any additional thoughts about adding additional valves in the future to isolate these mains?
Yeah, that'll be on the twinning. So the twin trunk that the city's designing right now will go from valve chamber 2 here to the water treatment plant, and that'll be a new system designed to current standards with and all those kinds of requirements. So that'll provide the redundancy and if additional or different kind of repairs are required on this existing portion, that'll allow the city to be able to go and address the existing feeder main.
There's another question here. In relation to the pipe that was repaired in place, so those 21 sections there that we put the concrete encasement around, was there anything done on the inside of the pipe, or was the inside of the pipe okay?
Yeah, from what we were seeing, inside the pipe was okay. There was no concerns there. From our forensics, it didn't appear that it was anything from the manufacturing process. We didn't find any issues with the lining on the sections that we did remove, obviously. So in those phase 1 pipes, those first 5 pipes that were removed, the testing on that proved out that it did meet the C301 design requirements. It was not like a manufacturing issue, and we didn't have any concerns with the existing pipe. So that again factored into why, how it was manufactured. Obviously, there's issues like once it went into the ground, but yeah, the lining we found we didn't have a concern there.
Okay. Can you comment? Question here about how long it took to kind of, if we go back to the phase 2 repairs, and there's 21 of them, so there's 21 pieces of pipe or segments of pipe.
Mm-hmm.
How long did it take to for you to repair each segment of pipe? would you say?
That
Like
was
each-
about
like
10,
each section.
10 days. So the phase 2 repairs, again, coordinated by Graham, they came up with a work plan to have, I think there was a minimum of like 4 independent work sites happening at any one time. So they had therefore civil contractors in place. They came up with a work plan for how to stage and deliver this. The takeaway that I had from this is like we're working along the Bow River, alluvial kind of floodplain. The geology there is like a lot of pit run, river run, and all of these were a lot of this was done with hydrovac, and the amount of hydrovac and the time to do the hydrovac, especially you're running into those large cobbles and boulders and things like that. That was a really slow process in this, but once they got their system in place and those initial kind of like excavating and exposing it, and working 24/7 as well, is about 10 days per site, and then completed overall in about a month time frame there.
There's lots of people on the line yet, lots of questions. So are you okay with a little bit of time yet, Craig?
If we're able to extend it, yeah. Thanks everyone for the questions. I already told anybody who I knew was attending, no curveballs, no hard balls, no questions about hot dogs or sandwiches.
I deleted that one, Craig.
You deleted the hot dog question? Okay, good.
I did actually, yes.
Yeah, okay. It is getting close to lunchtime here in Calgary, so I'm hungry. That's the main reason.
Understood. Here's a good one. Was the entirety of the Feedermain out of commission for all phases of the work? Also, what was the total duration that this Feedermain was out of commission for?
Yeah, so the entirety of the Bearspaw Feedermain for the first 2 phases was shut down. I can't recall if between valve chamber 2 and 3 it was still in service. So the Bearspaw Feedermain wasn't. It's not just this 10 kilometer stretch. I believe it's about a total of 15 kilometers. But yeah, like the reason why like the water restrictions were in place is because like this is like the backbone, and I believe it was out of service. If there's anyone in the city, it stands to correct me there. But and then like the total duration, in terms of months, I would say it's about 3.5 months total duration that there was water restrictions in place.
For the phase 2 repairs that Graham took, was the main live when that work was being done?
No, it was isolated and it was drained, and then again same thing. We need to fill it, test it, and then water quality was tested before it was put back into service. All those things, and that was one of the things with it came down to one thrust block. That obviously the last one to get poured, we installed temperature sensors on that one to make sure that there wasn't too much of a differential between the concrete curing temperature and like the water temperature. We didn't want the colder water to come in there and inhibit or affect the curing on the concrete. So we were monitoring that as we brought it back online. So we wanted to get it to certain temperature, cure it enough that when we filled it, it was ready to go back into service and be pressurized again. So yeah, that line was drained. Refilling the line took about 3 days to fill and test and pressurize the system to get it back online.
Thank you. Some questions again about the repairs, like the encasement repairs. That's like a permanent. This isn't like a temporary Band-Aid kind of thing. That the design for that was full service, full pressure.
Correct.
Long-term design. There was not.
Yeah.
Not a temporary. Do you have any commentary on that?
No, it was designed to basically replace the wires. Like these all have broken wires. That's the distress. Like there wasn't joint or like fluid integrity issues. This is wire breaks, and so this was to replace the lost the lost pre-stressed wires and reinforce the pipe to keep it shaped, keep the water in place, and yeah, designed for full service.
This is a good question, and maybe. So the question here is, I mean, if I recall, I mean, you were involved in this more or less 24/7 for quite a while. This became your life. So the question here, maybe it's a personal question potentially. Is there anything you wish you would have done differently, or is there anything you think went very well you're most proud of? It's not a technical question. I'll give you some time to think about it.
But that's one of the things that I've thought about it afterwards is like emergency responses. There is an emotional side to it as well, right? And like you're working long days. It's high stress. Some of the things that, and it's a credit to, but I think like this was the approach for a lot of the different staff that we're working on is like having that cross shift. And, we did put in, I did put in, 2 weeks straight on site, not 24 hours, like 15 or 16 hours or something days. But then having that ability to have the cross shift and making sure that you had that time off, that time away to go unplug. And I know that was something that the city staff were doing as well. So I think that was, and just learning from emergencies, learning how to respond to emergencies. I think I learned a lot from that, and being able to, be in there, be on it, but then also have that time away and be able to recoup and get back. Of course, some of the crews, not so much. So credit to the people that are in the trenches there, obviously, right? So, but yeah, in terms of like what could have done different, nothing really coming to mind. But yeah, just learning, the importance of having the cross shift, having the backup, training your replacement kind of thing. We did involve quite a bit of junior staff on this, so they could have that exposure and those opportunities, and then also being there to support on different aspects. So.
Excellent.
Thanks for that question. Whoever asked it, by the way, that's a great question, and something that, engineering, I remember like they're saying like there's no tiers in engineering, but there is the soft side. Some of these emergency things, it is tough. And yeah, I think one of the things they had was safety moments and things like that throughout, and some of it was focused on that, mental health. And I think that's really important to remember through something like this.
Easier question. Did any other utilities have to be relocated to accommodate the repairs or the work that was ongoing?
No, there was maybe a couple of like catch basin leads or service alterations, but in terms of third party, like private utilities, gas, electric, phone, there's no relocations, and no major relocations were required.
Can you comment on, I mean, we did the forensic kind of transient and pressure analysis, looking at past data leading up to that, to the break. Was there any recommendations for installing pressure monitors on the pipe, or is there no need to have such monitoring? Can you answer that?
I can't really, comment on that, but I know that there's no pressure monitors. From what I know, our review was that like there was it was not related to a pressure incident. So.
Okay. I think we're good, Craig. Like I've seen we're tapering off here a little bit, and but I mean, I think we've answered the majority of the questions. So again, just want to thank you for being here, and thanks for your time and great presentation. So yeah, just as we close out, just want to thank all of the QIC members here listed on the slide here. If you're interested in becoming a member, by all means, go to the QIC.ca website and log in. Like Craig maybe explained before, lots of good benefits here in terms of these webinars, which and then also the academies and the workshops. So those are all coming out. It's an excellent forum to get together and share knowledge and information. So just as a reminder also, and I don't know if Craig got to this or not, but the next webinar coming up here, and that'll be on the third Thursday of the month, is a proactive safety culture, building sustainable and resilient teams. So that'll be our next webinar coming up here in June, and hope we all can join us for that. Otherwise, have yourselves a good rest of the day, and thanks for joining us today. We'll see you next time.
Thanks, everyone.